Hey there everyone, Mr. Lewis here. Hope you're doing well. Welcome to your very first video lecture for AP Microeconomics. And I wanted to explain a little bit first how these video lectures work. So what I'm about to do in a moment is flip the screen, and what you'll see are your Google slides for Unit 1, Basic Economic Concepts. And I'm going to walk through each of those slides and elaborate on each of those slides just as I would for an in-person lecture using the same exact notes. So these are the same slides that we use during in-person lectures. The only disadvantage is that you cannot ask questions on the spot. However, that's what email is for. And if that doesn't work, then I'm always happy to set up a one-on-one Zoom or discuss things with you during Wednesday office hours to try and elaborate even more on the topics that you're about to see in the notes. So without further ado, let's begin section 1.1 of Basic Economic Concepts. And we're actually going to cover the first 3 sections of Unit 1 today, but we'll take it one at a time. Here we go. Okay, Unit 1, let's kick things off. This is titled Basic Economic Concepts. And within Unit 1, there are 6 sections. We're covering the first 3 today in this lecture. 1.1 deals with the concept of scarcity. 1.2 is resource allocation and economic systems, and then 1.3 is a graph that we call the production possibilities curve. And really what we're trying to do here is set up the foundation for everything else that is to come. So section 1.1 is very brief. Section 1.1 is there to make sure that we all understand what this course is all about. The science of economics itself is defined by this idea, scarcity. There are scarce resources available to meet essentially unlimited wants and needs in a population. So the central question becomes, who decides how to allocate all of those resources? How much should those things cost for all of us? And who should get what? So who answers those questions, and really the answers to those questions themselves, determines what type of economic system we live in. So how do we deal with scarcity? Resources that are scarce carry value. Otherwise, they're not scarce, right? Anything that is limited carries some value because of that scarcity. And some resources are in greater demand than others. And so how do we take what resources we have and try to meet all of these needs and wants of the human population? However we decide to answer that question in terms of resource allocation strategies, that determines what type of economic system we're operating under. And so going back to those questions, what gets produced, how are goods made, who gets to consume goods and services? Again, the answers to those questions determine whether we are living in a market economic system, a command economic system, or somewhere in between, what would be called a mixed economic system. In a market economic system, the government is completely out of the picture, or what we would call laissez-faire. They are hands off. Whereas in a command economic system, the government is really answering all of these questions for the entire population. So in the free market, private individuals and private companies, or what we call firms, determine what gets made, how much those things cost, and all those other answers to the questions that we posed over the last couple slides. One of the most free markets in the world, I should say one of the freest markets in the world, is Singapore, because the government has very little regulation. Whereas in Cuba or China, for example, there is a great amount of regulation and government control, although China has been leaning more and more toward the market side of this spectrum over the last 50 years or so, and their economy has really been booming as a result of that leaning into a little bit of capitalism. Now, The free market is advantageous because it's very efficient. It responds very quickly and efficiently and effectively to the needs and wants of a population. Unfortunately, within a market system, there are also large gaps in wealth distribution between the rich and the poor. In a command economy, it's very inefficient because you have this central authority, the government, trying to make decisions for all of the individuals within a population. And the bigger the population, the more difficult it is to make those decisions. So it's very inefficient. On the other hand, it is quite fair in terms of wealth distribution, trying to ensure that everyone has an equal amount and everyone has enough. But as we've seen throughout history, unfortunately, with these types of systems, usually comes some type of totalitarian control. Often that central government is protected through the abuse of authority. Now, the truth is, most economic systems we find in the world today are mixed in some ways. Even the United States, we would lean toward the free market side of this spectrum, but in reality, we have a mixed system because there are some public goods that are produced and distributed by the government. So those are the three types of economic systems. And you can see on this chart how this spectrum is sort of laid out from pure competition or the private, pure, laissez-faire free market on this side, all the way over to the pure, planned, centrally planned economy or communism or command system on this side. Finally, the last section for today, the production possibilities curve. If each country only has so many resources to work with, and they have to make decisions about how best to allocate these resources, then we need some type of model on which we can see the different outcomes, the potential outcomes of the allocation of those resources. And then we can make decisions using that model. And you'll see that in economics, we're always using models and graphs and charts to try and analyze these decisions. And this actually is occasionally referenced by economists as the guns versus butter dilemma. Meaning, as a government, you could put all of this money into your military, right, and defense, guns, or you could sink money into domestic things like maybe healthcare or Social Security or what have you, and that might represent butter, putting butter or food on people's plates, so to speak. So it's meant to represent this relationship between cost and benefits, because here's the thing, you only have so many resources. We have scarce resources. We are battling scarcity, and we have to try and make efficient decisions based on those scarce resources. So we can make a bunch of guns if we want, and we could produce up to this point. If we put all of our resources into gun production, we would be all the way over to the left of this curve, because that would mean zero butter and as many guns as we can produce, or the top point of this curve. On the other hand, if we put all of our resources into butter production, we're going to be all the way over on the other side of this curve, way down here. Now, there are various combinations of these resources, right? We could produce this much Wada or this much Dasani, but there are different combinations of each of these resources as well. We don't just have to choose one or the other. So you'll notice on this graph down here, and let's make that a little bit larger, the points that are on the curve itself, B, C, D, and A, those all represent efficient use of our resources, because we're pushing our resources to the maximum capabilities. We're going all the way out to the frontier, as it's called, the maximum potential of these resources. It doesn't really matter what combination we're making. whether it's 100 units of food on this particular graph over here at point B, or let's call this 160, it's more than 150 units of clothing on this x-axis, or a combination of the two goods. Either way, we're on this frontier. We are making the most of our resources. At point E, we're underutilizing our resources. We're not making the most of what we could produce with the resources that we have. Whereas point F is actually beyond that production possibility curve. This solid line, this solid curve here, not the dotted lines, but this curve itself represents the maximum potential. So point F would be basically impossible. So on any production possibility curve, you're going to have a few things. We're going to have one product on the y-axis, in this case food. You're going to have a product on the x-axis, in this case clothing. And then we're going to see the maximum amount produced of either good. On this particular graph, we don't see that number actually listed at point A, but most of the time it will be. And then we can see different combinations, different levels of production for either good. So at point C, we can make 100 units of clothing. At point D, we can make 150 units combined with 75 units of food or 50 units of food, respectively. And then, as I mentioned, we have our frontier, the maximum capabilities of our resources. That's if we're using those resources efficiently, if we're allocating them efficiently. And then, of course, we have these different points along that curve that are efficient points of production. We have the impossible point of production in point F, anything outside of the curve. And then the underutilization or wasted resources, point with point E there. And that would be considered inefficient, right? So we have inefficient, efficient, and then impossible. So what do we use this thing for? If all of these points are good, B, C, D, A, how do we know which one is the best? Well, we're actually going to find that answer out later on in terms of should this particular economy, should this particular country or business or whatever it might be that we're being shown on this production possibility curve, should they focus on food production? Should they focus on clothing production? What should they do? Well, we're going to find that out later. Today, what I want you to walk away with is this skill. Being able to use the production possibility curve, not just to identify efficient points of production, inefficient points of production, impossible points of production, but also costs and benefits. Anytime we're shifting production from one point of this curve or on this curve to another point on the curve, we're gaining something, but we have to give something up. Remember, any point on the curve is efficient, but it also means that we're using every last inch of our resources. So, if we want to make more of something and we're already on the curve, one of two things has to happen. Either we need to expand our resources and our production capabilities. Maybe we add more workers. Maybe we get more money to work with, more capital. Maybe we get some new technology that enables us to produce things faster and cheaper. Any of those things could actually expand this curve to a point where we could produce at point F efficiently. But if that's not the case, we have to give something up. One of the major themes of this course is cost and benefit. There's always a cost when there's a benefit, right? Or in other words, there's no such thing as a free lunch. To get more of something, we have to give up something else. If we were moving from point C to point D on this production possibilities curve, in other words, if we wanted to increase our clothing production from 100 units to 150, we would have to give up some food because we're already using all of our resources. So, At point C, we're producing 75 units of food. At point D, we're producing 50 units of food. So we have to give up 25 units of food in order to produce those extra 50 units of clothing. That is how we would analyze and measure benefit and opportunity cost on a production possibility curve. In this case, we don't just call it cost because it's not just a dollar value. It's an opportunity that we're losing. We're giving up 25 units of food that we could have produced. So we're going to go ahead. Sorry for the interruption with the announcement.
Please report to the assistant principal's office.
Okay. So as we move from point C to point D, we have to give something up. It's an opportunity that we're missing out on, or in other words, an opportunity cost. So here we see the answer to that question. What is the cost of shifting production allocation from point C to point D? The opportunity cost would be 25 units of food. So here's another example. If we were shifting from point A to point B on this particular production possibilities curve, what would the benefit be and what would the opportunity cost be? So let's analyze what we have here. Output of wheat on the y-axis, cotton on the x-axis. When we move from point A to point B, we are gaining on the x-axis. We go from being able to produce 300 units of cotton to 400. But in order to do that, we have to give up 200 units of wheat at point A to 160 at point B. We have to give up 40 units of wheat to produce those extra 100 units of cotton. And because of that, as it says up here in this green box, we can actually calculate the opportunity cost of each ton of wheat or each ton of cotton or each unit of each. We can tell on average per unit what we have to give up of the other. So then we can start comparing and figuring out what are we best at doing? What are we more efficient producing than maybe other countries around the world? But we're going to look a little bit more at that when we get into another section. You can see here, if we have a constant trade-off, so let's say on the y-axis we have cars, and on the x-axis we have computers, and there is a constant opportunity cost. One car equal to 2 computers. In other words, for every car we don't make, we can make 2 more computers, or vice versa. If there is a constant trade-off like that, we're going to end up with a production possibilities curve that isn't so curvy. In fact, it would be a straight line. We would have a linear production possibilities curve because of that constant trade-off, that constant ratio, which would then become a consistent slope of the production possibility curve itself. So, as I mentioned, there are some things that can shift the production possibility curve outward. Here's a helpful short video if you'd like to watch Mr. Clifford explain this. He makes some great YouTube clips for AP Micro and has been doing it for years. So I highly encourage you to use his videos if what I'm making for you just doesn't get it done sometimes. But I know I've learned a lot from him over the years as well, especially when I was first teaching this course. So he's very helpful. But this specific video goes over the expansion of the production possibility curve. As I mentioned, there are a few things that can make that happen. Let's say we get some new production technology and we can make more of something with the same exact resources we had before, the same labor, the same factory, the same capital, all of it. Well, that would expand that production possibility curve. We're now really expanding our total capabilities, our total potential, right? As a firm, a company, or as an economy, a government, a country, because of this new technology. We could also see an influx of labor or capital or whatever it might be. Any of these, what we call factors of production, things that we need to produce goods, if we get more of them in some way, that is going to expand our overall production potential. So take a quick look at this video if you have a moment, but I'm going to, for today, say so long and ask that you complete the level up challenge in Buzz. So you'll see a level up challenge for the production possibility curve and the other items that we just discussed here in sections 1.1, 1.2, and 1.3. Please go ahead and attempt all of those different levels. You have to earn 100% on the first one before you can move on to the second, and then so on and so forth, to ensure that you are really mastering each little bit of content before moving on to more difficult items. So take a look at that, complete that please, and then we'll move on with Unit 1 in the next section, Section 1.4. All right, thanks for tuning in, everyone. I will see you next time.